For this lesson, we're talking about multiple representations of functions. And this lesson is really focused on understanding functions and understanding how you can apply it in different situations. Okay? And so, for this lesson, we're just going to go through a lot of different ways we can look at one problem. Okay? So my problem, it says Daniel receives $4 per week for allowance and earns an additional $6.50 for each lawn he mows. Okay? So, it says write an equation to find the total amount Daniel earned for M lawns mowed in 1 week. Okay? So we're looking for a total. Okay? So, well, let's say since I'm looking for a total, I'm going to define that variable as T. Okay? I'm going to call T is my total. Okay? They defined, actually, M means how many lawns Daniel mowed. Okay? Some other pieces of information that I need to know. Okay? He's earning $4 per week for his allowance, and he earns an additional $6.50 for each lawn he mows. Okay? So, when we're working with these word problems, we have to learn how to break down what information is there. Okay? So, we need to create this equation. Well, for me, my total, total, that's going to be on its own side, right? That's like in functions, usually it's represented by y, the output, right? So all this stuff is going to happen in a week, and it's going to equal his total. Okay? Now, we know that we need to have some kind of input, and that input for this problem is M lawns mowed, okay? Because he is going to be mowing a certain amount of lawns, but we don't know how many, okay? And we defined our variable as M. Okay? From there, we need to say, okay, well, let's look at some of these values. We have $6.50, and then we have $4, okay? Well, what do we know about those values? Well, $4 is what he gets for his allowance. And you have to think, does that change? Can anything change, how much is he getting for allowance? Could he do something and get $8 for his allowance? No, that's not how his allowances usually work, right? If you have a set amount, it's not like, hey, if you're extra good, we'll give you twice as much. Right? Maybe some parents do that. Okay, I didn't get an allowance, so I don't really know. But so that $4, usually allowances, it's a set amount. Okay, so what I'm going to do is I'm going to add 4. Okay, and I'm not going to put that next to the M because it's just 4. It's always going to be 4 that we're adding. Right? We're not multiplying it by how good he is, how good his parents deem him to be. No, it's always 4. So I'm not putting it by a variable. But what could change is how much he's earning from mowing lawns. Okay? And so I have 6.5, and normally I would write in the 650 because we're talking about money, but I wrote it too tight, and so I don't have space to, and I recognize that 6.5 is the same as 6.50. Okay? But so here's my equation. And the reason I set it up this way, right, is because I know I should have my output, my total, okay? And that's T. I should have 650, and I need 4, and I need an M. And I put the 650 by the M because, look, he earns $6.50 per lawn he mows, which means if he were to mow 3 lawns, he wouldn't earn $6.50. He would earn $6.50 times or multiplied by 3, okay? And then whenever we have that total, we would add $4 because we know he automatically earns $4 per week for his allowance, okay? That $4, we're not multiplying it by anything again because it's not based off of, he could increase it by good behavior or doing this or that, okay? The thing that could increase based on something is at 6.5 because it's based on how many lawns he mows, okay? So there's my equation. It could also look like I said, T equals 650 M plus 4, okay? You could also write it as T equals 4 plus 6.5 m, right? That's just using the commutative property of addition, right? We just switched what order we're adding those things. So there are a few ways that your equation could, what it could look like. It could look like more still, okay? All right, define the variables. What define a variable means is simply saying, what does it mean? Okay, define. Like you're defining any word, you're just saying, what does it mean? So, T means total, right? M means the number of lawns mowed. Okay? So that's what it means when it says define the variable. It's just saying, what does it mean? Make sure you understand what it means. Otherwise, you could get into trouble. For letter C, part C, it says make a function table to show the relationship between the number of lawns mowed M and the total amount earned T in 1 week if Daniel mows 1, 2, or 3 lawns. Okay, so here we go. I'm going to make my table, and we have learned that function tables can take a vertical or horizontal shape. We're going to go vertical, okay? So my input, okay, I need to understand what's my input. My input would be lawns mowed. Lawns mowed, and that's represented by M, lawns mowed, and the output is total, and that's represented by the variable T. Okay, a lot of times that will be represented by X and Y, okay? But if we look at it, X would normally be in this spot and Y would be in that spot. So it makes sense that those are our inputs and our outputs. And you would need to input a certain amount of lawns mowed in order to get out that total. You couldn't find out your total until you mowed those lawns. Okay, and it said test for 1, 2, and 3. Okay, well, if we have our function, okay, all we have to do is we need to plug in our values, okay? So let's do the first one. T equals 6.5 if M equals 1, and it's adding 4, okay? So we've plugged in our value. Well, 1 times 6.5 is 6.5. That's the identity property of multiplication. Add 4. Okay, so we get 1050. Okay, or 10.5, right? From there, we need to do, okay, let's try number 2. Well, T equals 6.5 multiplied by 2, and it's adding 4, right? So we're just plugging it into our equation. From there, we get T equals, well, 2 times 6.5 is going to be 13 plus 4, and so T will equal 17 in this one. 17. And let's do the third one. We have T equals 6.5 multiplied by 3, okay, plus 4, and we're going to get, well, that's going to be 19.5 plus 4. T equals 23.5. 23.5. Okay. So I have a graph created over here because, well, this was the answer to C, right? It said to make a function table to show the relationship between the number of lawns mowed M and the total amount earned T in 1 week if Daniel mows 1, 2, or 3 lawns. Perfect. So we've got C right there. D is graph the ordered pairs. So in this case, this is actually M and this is T, okay? This axis represents lawns mowed. Okay, and this represents total. Okay? So, here we go. Well, I'm pretty confident that I can put 1, 2, 3, 4, 5, 6, 7. Okay? The one that's going to be a little trickier is over here. Okay? And that's because, well, one, these are like 10.5 or 10.50, 23.5. So I'm going to say, right, the highest number is 23.5. So what if I go by intervals of 5? Okay, 5, 10, 15, 20, 25, 30. Okay, so it's going to work very nicely. I'm going to fit all my data in here. Okay, well, when x, or in this case m, is 1, okay, t is going to be 10.5. So I'm going to go to 10, and it's just a little bit above. Remember, each box is worth 5 when going up. So I'm just barely over where 10 would be. Okay? For 2, when it's at 2, it's going to be 17. So there's 15, and it's going to be a little higher than the last one. So probably about there. It should be a little below half. And for 3, when it's at 3, it should be 23. Well, here's 20. Okay, 23.5. And so that should be approaching 25. Okay, but not quite there. And, well, here we go. We should be able to get a function similar to this, and we notice we should get, and this is going to be, it's not going to be perfect, okay? It's not going to be perfect for you because we're approximating putting those points down right on 10.5. But we see, we pretty much have a straight line here, okay? So that makes sense for one of our linear functions, okay? So there is D. Okay, we've graphed D over here. It says, how much will Daniel earn if he mows 6 lawns? Well, again, this is really similar to part C, where all we had to do was plug in the value. So all we need to do, again, is plug in our value. So it's going to be T equals 6.5 multiplied by, in this case, 6 lawns mowed plus 4. Well, this is going to get us 47. T equals 47 plus 4. So T in this case would equal 51. Okay, so his total in that case would be $51. Alright, and now identify the independent variable, or the independent and the dependent variable for this one. We have one variable that depends on the other. Something has to happen, okay? And it's usually, right, it is our input. Our input is representing our independent variable, okay? And then our dependent variable is the output. So, in this case, the independent variable, is the number of lawns mowed m, okay? Because it is represented by n, okay? And then the dependent variable, is the total T, okay? Because the total depends on the number of lawns that Daniel would mow. So if we want to figure out how much the total is, we have to wait until we know how many lawns he has mowed, okay? So I hope that helps with some of these problems that you will be seeing. Oh, but I probably should actually bring that up so you can see that on the screen. Oh. Okay, that final answer. Okay, so the dependent variable is the total T. Hopefully this helps you with the work that you will be doing. Good luck.